Have you ever wondered what kind of math problem solver are you? Well, you're about to find out. Problem solvers typically come in three distinct flavors. Cunning solvers get the problem correct, but their methods are either a bit sketchy or not totally convincing. They're sneaky. Crazy solvers are just the opposite. They go overboard in their solution with an overzealous approach that is simply overkill. And then there are the clever solvers. These guys find the perfect solution, which often sheds creative insight into the problem. We're going to assess your problem-solving skills with the following math competition problem. F and g are both cubic polynomials. You're given that f of 3 equals g of 5, f of 5 equals g of 7, f of 7 equals g of 9, and f of 11 minus g of 13 is 24. Based on this information, can you find f of 17 minus g of 19? Pause the video to give this problem some thought, and when you're ready, join me for the 3 different solutions to see which category of solver you fall under. Let's start with the conniving problem solver. What's to prevent him from setting f of 3 and g of 5 both equal to 0? And how about f of 5 and g of 7? Yeah, let's make them both 0. And hey, we're on a roll, so let's make f of 7 and g of 9 also equal to 0. And since the difference between f of 11 and g of 13 must equal 24, let's assign artificial values of 25 to f of 11 and 1 to g of 13. Now we have all the ingredients to figure out f of x and g of x. We'll attack f of x first. Since we forced zeros at 3, 5, and 7, we can write f of x as a product of these 3 linear factors. And since we assigned f of 11 to equal 25, we can solve for the polynomial constant m. Plugging 11 in for x, we get 25 equals m times 8 times 6 times 4, so m is 25 over 192. And f of x is now fully defined as follows. Moving on to g. We're going to get the formula for g of x exactly the same way as we did for f. Now we're ready to evaluate f of 17 minus g of 19. For f of x, I'll plug 17 in for x, then simplifying, I'll get this product. Here's a quick trick for multiplying 14 by 12. Since they can be written as 13 plus 1 times 13 minus 1, they're just the difference of 2 squares, so we get 168. Okay, so f of 17 is 25 times 1680 over 192. We'll follow the same steps to get g of 19, which comes out to 1680 over 192. So their difference looks like this. This difference becomes 24 times 1680 over 192. And since 24 over 192 is 8, we get 1680 over 8, which comes out to 210. Congratulations to all you conniving problem solvers out there. You got it correct. Now let's move on to the crazy problem solving method. To Crazy's credit, he's going to approach this in a more convincing way. You won't feel ripped off that it was done by assuming specific values. Let's first rewrite the information given by subtracting g from both sides. Since the g input is always 2 more than the f input, we can create a brand new cubic, call it h of x, and write it as f of x minus g of x plus 2. Since h is also a cubic function, we can write it as ax cubed plus bx squared plus cx plus d. So when x equals 3, we get the following equations for h. When x is 5, we get this. Then moving on to x is 7, we get this, and finally when h is 11, we get this. Notice that these are all linear equations, and we can now solve for the coefficients a, b, c, and d using matrix algebra. Crazy Solver can smell the solution, but he first needs to multiply both sides by the inverse of this 4x4 matrix. And now he can get the answer to the problem by plugging in 17 for x. We can get this in one fell swoop by front multiplying both sides of our matrix equation by the following 1x4 matrix. And sparing all the gruesome details, I can assure you Crazy Problem Solver will eventually get 210. Now finally, let's see how the clever solver does it. He will also define h of x as f of x minus g of x plus 2. But instead he'll write it out as a product of linear factors. Just like before, he'll plug in 3, 5, 7, and 11 for x into h of x and get the following 4 equations. But now he focuses on the first 3 equations and notices something interesting. For the top equation, One of those three constants must equal 3 in order for h of 3 to equal 0, right? Let's agree for now that it's a. Then for the second equation, one of those constants must equal 5. Since we already set a equal to 3, let's make b equal 5. And for the third equation, using the same reasoning, we'll set c equal to 7. We can easily assign the values like this without loss of generality, since there are exactly 6 different permutations we can select for a, b, and c. Let's stick with the values in red and plug them into the fourth equation. We'll get h of 11 equals k times 8 times 6 times 4, which equals 24. Solving for k, we get 1/8. And now, h of x is fully defined and operational. So let's plug in 17 to get our answer. That simplifies to 14 times 12 times 10 over 8. We know from the conniving approach that the numerator is 1680. And 1680 over 8 is 210. Let me know in the comments below which type of problem solver you are. And as always, thanks for watching and see you soon.